All right, so here we're doing the humidity is currently 32% and falling at a rate of 4 percentage points per hour. So if we think about that, if it's falling at a rate, that's going to be a negative 4 percentage points per 1 hour. Okay, so that's really what it's doing. And so it's currently 32%. So what we're supposed to do is estimate the change in humidity over the next 20 minutes. Well, now we have different things. We have minutes here, we have hours here. So what do we need to do? Well, let's convert this minutes to hours. So the first thing we're going to do is say, well, 20 minutes over 1, and then our conversion factor is going to be 60 minutes in 1 hour. And so then our units, if we go ahead and cancel those, that minute cancels that minute, and we're left with hours. And so that's going to be 20 over 60, or it looks like 1/3 of an hour, okay, if we keep it as a fraction. So now what is the change? Well, our approximate change is going to be equal to our rate of change. Okay, so our rate of change is negative 4 percentage points per hour times how long did it go, our interval. And sometimes we were labeling it h, so we can call that h if we want. And so what is the rate of change? Well, that's a negative 4 percentage points per 1 hour times, and then we can do 1/3 of an hour. Okay, so that hour is over 1. And so what happens is our hour cancels our hour, and all we have to do is we have to take negative 4 divided by 3, and so that's going to give us a negative 1.33333, and it's going to be repeating like that forever. So let's approximate that by a negative 1.3 percentage points. Okay, because we don't have per hour anymore, we just have percentage points. And so that is going to be the change in humidity over the 20 minutes, next 20 minutes. Okay. All right, so now it says for part B, estimate the humidity 20 minutes from now. All right, well, that's going to be basically our approximate humidity is going to equal, well, now we have to take our initial because we have to have something, and then we're going to add to that our change. Well, our change is this. So we're going to take 32, and then it's going to be, well, maybe we should write it in word form so we know what we're plugging in here first. So we're taking the initial plus our change. And again, our change we just did right here. So it's going to be the 32, and our change was minus 1.3. So that's going to be approximately, because this is approximately, that's going to be about 30.7%. Okay. And here percentage points, we could have said negative 1.3% if we wanted to. But they started it with percentage points. So but this is really what we're looking at. We're looking at 30.7%. Okay. So that's how I would work that one. All right, so the next one says the daily production level is currently 100 filters, and it's increasing by a rate of 3 filters per day. Estimate the change in daily production over the next week. All right, well, A is going to be, what do we have? Well, we have our approximate change is going to be equal to our rate of change times our interval again. So we're just kind of writing it out every time so we know what's going on. Our rate of change, 3 filters per day, times, well, we're doing it for a week, so that's going to be over 7 days. Well, now our days cancel. And so we have 3 times 7, which is 21 filters. Okay, so that's the approximate change. Well, now for B, it says estimate the daily production in a week. All right. So, and again, we're going to do kind of like we did here. Now it's going to be approximate production. Well, that's going to be our initial plus our change. And so that's going to be 100 plus 21. And that's going to be 121 filters. Okay, so that's going to be our daily production in a week. Okay, so that will be where we're at. All right, so that's again, we're just using approximate change, approximate production. That's just rate of change times interval, and this is the initial value plus our change, and we can get all those solved. All right, what about the next one here? Well, we have write a linearization for f with respect to x, and then we have to use that linearization to estimate f at the given input. So what we need to do is we want to say, well, f linearization of x is equal to, and now we're doing our f of c, and so in this case, it looks like c is equal to 3. Down here, looks like C is equal to 10. So we kind of need to know that. And so we get that just from right here. So it's going to be f of C, which is going to be 17. Then it's going to be plus our f prime, which is 4.6, times, now we have x minus C, which is 3. So that is what they want us to do for finding a linearization for f with respect to x. And so we can plug in any x now, and we can find out what that f of whatever that x is. And so then they say, okay, well, now we want to find fl of x, which is 3.5. Well, so we're going to have 17 plus 4.6 times 3.5 minus 3. And if we plug that into our calculator, 17 plus 4.6 times 0.5 is going to give me 19.3. Okay, now we don't know units or anything, so we just have a value 19.3. So we have our function and our value. So same thing works here. Well, we're looking for f, well, I guess it's a little lowercase, f of L of x is equal to our f of c, which is 5, plus f prime, which is negative 3, times x, and then it's going to be, well, our c was 10, so minus 10. Now, could we rewrite that? Well, we could. We could say, okay, well, that's equal to 5 minus, oops, it's 0.3. I don't know where I got just a 3 here. Minus 0.3. And so we could say minus 0.3 times x minus 10. And so either way works. One has adding of the negative times, and one we just have subtract that. Okay, so either way will be fine as far as how you can write it. Now B says now we want to find FL of 10.4. So that's 5 minus 0.3 times 10.4 minus 10. And if we plug that into our calculator, 5 minus 0.3, 5 minus 0.3 times that is going to get us 4.88. Okay, and so that would be the value. Again, we don't know what the units are, and so we just have that. And so then we can have one of those two for our linearization function, and then the 4.88 for our value here. All right, so let's stop there, and then we'll come back for more examples.